see. Can the first speaker please set up while I'm here? Okay. Okay. So welcome to this this session. It's a quantum session. So I'm sure. Well, okay. So I'll tell you from my viewpoint. Quantum session ideally is a 2-for-1 deal in the sense that not only do I find out about interesting things from a quantum viewpoint, but it also the talks ideally make a deepen an understanding of something classical, and I think that's true about the papers in this session. So let's see, we'll start with a paper by Vazirani, Vidic, and Yuen on parallel repetition via fortification, analytic view, and quantum case. So as you know, parallel repetition is it's quite fundamental, and it's really unexpectedly difficult to show that when you do a parallel repetition, you get this exponential fall off in error. And there's this technique of fortification that was introduced by Dana Moskowitz a couple of years ago, where instead of analyzing the given game, you modify the game. Now, what this paper does is it takes this Moskowitz technique and extends it from 2 players to multiplayers, from classical to quantum, but also it changes the view of this, from combinatorial to analytic, thereby, not just extending it to the quantum case, but also eliminating the technique itself. The second paper in this session is classification of reversible bit operations by Aronson, Greer, and Schaefer. And here, the paper is purely classical, I believe, but the motivation is quantum. And the issue is how should you formalize this notion of reversible bit operations, and in particular, how do you formalize the role of an ancilla in these bit operations? And the correct answer, which is quite elegant, comes from this quantum viewpoint, which says that if you're going to use these reversible bit operations in a quantum setting, then you can use an ancilla, but you had better clean up after yourself. And so that gives you the nice, elegant definition in which this paper is set. The third paper is non-deterministic quantum communication complexity by Berman, Christandel, and Zidane. I'm tempted to say Zidane, but I don't think it's quite the right thing. So this paper, one way to view it is, there's this beautiful result by De Wolf et al., which shows how you take, this connection between 2-party non-deterministic quantum communication complexity and log rank. So what this does is it generalizes it to the multi-party case and shows that there's a connection to the log of the tensor rank. And so now if you look at related problems, then, in this non-deterministic model, then you can, for instance, show that there's a connection to the value of the iterated matrix multiplication tensor, which is itself related to the matrix multiplication exponent. So again, there's a deep quantum classical connection. And the final paper in this session is Quantum Codes from High-Dimensional Manifolds by Matt Hastings. This tackles a really interesting open question on low-density parity check codes in the quantum setting. So in the quantum setting, LDPC codes suffered from this square root n barrier in rate, and so what he does is give a construction based on a certain geometric conjecture, which breaks past this barrier and gives almost linear rate. And the construction sort of is via dense packings in high-dimensional manifolds via tilings using a lattice. And so what Matt shows is that the rate of the code that results depends upon a purely geometric parameter called the Rivkin invariant. And so based on this geometric conjecture, he shows that if this geometric conjecture holds, then these packings imply a good code. So again, this beautiful geometric ideas are, I would imagine they're going to have further, ramifications, even if you're not interested in the quantities. So without further ado, shall we start with the first talk?